Hello. Thank you. Thanks, everybody. Before I begin my talk, I did not come alone. I brought a friend. This is Django Pony. And you can, whoever donates to the DSF first will win this Django Pony. And you can talk to my colleague Thibaut and Sarah. They're both wearing the bright green shirts back there. So if you would like to have a Django Pony of your own, you can donate to the DSF. Okay, so 1001 Nights. Actually, we're going to be talking about 1001 sites, specifically Django sites. And what I'm going to do is tell you a story here. So once upon a time, as all good stories start, there was an agency named Code Red, which is where I work. Building many Django and Wagtail sites, they must host them in a manner that would be pleasing to clients and developers alike. As the sites numbered in the dozens, then the hundreds, the magical lamp stack became burdensome. Weary with maintenance, fatigued by three-letter acronyms from the almighty cloud providers, they set sail for a new platform. So this will be a story of adventure, monsters, wisdom, and what we've learned on our journey to hosting 1,000 Django sites. So the background is, I work at Code Red, and we have a Django and Wagtail hosting platform, which is relatively new. That's codered.cloud. And recently, as of last year, we crossed a milestone of hosting over 1,000 Django sites, Django and Wagtail. So it's very exciting, and I just wanted to share kind of the journey. And just real quick, shout out to Wagtail because I'm a core contributor to that, and we do a ton of Wagtail. So if you're not familiar with what that is, this is what it looks like. It's basically a Django CMS built on top of Django. So it's pretty much the same as Django for hosting purposes. So the first story that we're going to look at is Sinbad the Sailor. And this is about how we found our technical architecture. So in the beginning, Sinbad is a young man. He's looking to make his way in the world. And like many famous great leaders of antiquity, he decides to use Django. So armed with Django, he seeks out fame, fortune, and riches, going to use Django to do this. On his very first voyage, he develops a few Django sites for clients, and it's a great success. It's a perfect fit. Setting sail to host his first site, he chooses the traditional time-honored LAMP stack, right? This is the Linux, Apache, MySQL, or Postgres, and P is, instead of PHP, we're going to use Python. So the first voyage, the seas are choppy, the Linux is unforgiving, but the Django sites run admirably. An excellent choice, he exclaims. But Sinbad has yet to encounter his first real challenge, and that is the den of pythons. So as more sites keep being added and created, Sinbad quickly learns that each has wildly different resource usage, different memory space, CPU time, different Python interpreters, different Python versions. All of this has to be managed and restricted. And it's a very difficult thing to do on one server. And it has to be different for every single site. They have to be separated. So, how do we tackle this challenge? How do we tame these pythons? Well, to start out, Sinbad employs the tools of his forefathers, and that is ModWSGI, subprocess, virtual envs, various system quotas, right? So you can set this up. You can isolate different websites on an Apache server using, WSGI and virtual envs, and it will give you a very basic level of isolation. But it still proves to be quite complex of a challenge. Apache processes can be interfered with by, the other Apache processes of one site can consume too much resource on the server for another site. So now you're looking at just running separate servers for all of these sites. And even with these tools, it's still kind of a difficult solution to manage when you have more than one site. But in the distance, they spot a great whale. Seeking safe haven, Sinbad discovers the island of Docker. At first, it appears to be a land of ease in development, the rich fruits, everything is good. But in production, the island begins to rumble. It turns out that this is not actually an island, but it was just the tip of a great big whale. And the whale in disguise destroys Sinbad's boat and much of his crew. And I just thought that was a perfect analogy for Docker, so I had to use it. Eventually, Docker is tamed and put to good use. So basically what happens here is, Docker is pretty easy to use and it's a good solution, but when you start managing many different websites with Docker, you can still run into some of the same problems, right? How do you configure, are you just managing a bunch of images? Do you need to get into container registries, having all of these sites, okay, getting ahead of myself, but having all of these sites just can create, even if you containerize them in Docker, you still have the problem of now instead of managing a bunch of Apache, you're managing a bunch of Docker containers. So you might be thinking to yourself, what about Kubernetes? But Kubernetes is more of a tool for if you are running many copies of the same site. So I have a bunch of workers, maybe I'm Netflix, and a new episode of something, White Lotus or whatever, something drops, and it's like, okay, everyone's watching that, so now I need to double the number of Netflix workers I have to handle the traffic. That's a great case for Kubernetes. But if you're an agency and you're building many different websites, you have to have those totally separate, and Kubernetes is not going to help you with running different things like that. So we just ended up going for a completely different approach, which is using Docker purely as an environment. So we have actually a single image for each version of Python, and that is it. Every single customer uses that exact same image, and their code is directly mounted into that image at runtime. So we've basically created a perfected Python environment for every different use case, and then all of this code can be managed separately and using a reusable environment. So that has actually worked really well. It's automated by an agent that's on our system, but there's still the problem, once you get to the next level up in the chain. So now you've got all of these managed, but now how do you manage all of these different code bases and all of these different servers that are needed to run this Docker monstrosity? So we've ended up creating an actual agent that runs on the operating system on the host. This is also written in Python, and this is able to manage all types of Docker containers. It's able to manage resources on the system, the file system permissions, everything. So now when we want to queue up a new environment, we can make a call to the agent and say, give me Python 3.9 or Python 3.13 with Django installed 5.2 on the server with the highest amount of resources available with X number of workers, and the agent can find the server that meets that criteria, spin up a site, and pip install everything into that new environment that it just created. So this is kind of, our goal was always to make the world's easiest Django deployment, or just the simplest Django deployment that's basically just pure Django. I don't want to have to write YAML. I don't want to have to write, manage a bunch of Docker scripts. I don't want to have to, do any of that kind of stuff. So right here you see a very basic Django site, right? There's a manage.py, there's a requirements.txt. This is pretty much what you get when you run Django admin start. Or in Wagtail's case, Wagtail start, and it gives you a similar boilerplate. So having done that, let me just show you kind of this is what we ended up with. So I've got my default Django site. I'm going to run cr deploy, which is our command line tool that kind of orchestrates all of this. So it's going to connect to the first available server. It's going to copy that code up to the server. It's going to queue a deployment, which is based on this version of Python that I specified. And in a few more seconds, you can see that it is now getting these deployment logs. So you can see the output of pip install. You can see it running migrations. It just collected static, and now the site is done in 19, 20 seconds roughly. So that is our total end-to-end process. We can deploy a Django site in about 20 to 30 seconds from zero to a fully working site with SSL and everything running on the internet. So that was like a huge accomplishment for us, and it took us many years to get to that point. So yeah, awesome. Thank you. Thank you. So that's kind of the technical side of things, which is what we as developers usually focus on. But there's more to running a website than just the infrastructure, right? Anyone who runs a site will know that you start running into some similar problems that Aladdin ran into, which is your wish is my command. Business challenges that come along with managing all of these sites. So for Aladdin, he starts out trapped in a cave. He receives a visit from his first client, who is a magical sorcerer. The sorcerer promises to reward him with riches if Aladdin can help him with a difficult task. And that task is actually fetching a magic lamp out of the cave. But soon, trying to complete this task, he finds himself trapped and stuck in the cave. So if you've ever engaged, if you're an agency or a freelancer, you may have found yourself trapped in a contract unknowingly. As Aladdin soon learns, web hosting requires an immense number of what I call assumed services, right? So things like 24/7, 365, having a 99.9% SLA. Is that something you really think of when you're, initially hosting a website? There has to be disaster recovery, right? What happens if the site goes down? How do you handle that? Do you have a plan established for that? And part of disaster recovery is not just going down, right? We usually think, AWS US East 1 went down, we better fail over to another region. But that doesn't happen very often, right? The disaster recovery that happens every single day is somebody makes a bad deployment, or a client deletes a bunch of stuff off their, from their database, or they delete a bunch of images or something, and they're like, oh, I didn't mean to do that, can I get them back? And a lot of times, that is considered a disaster because it may cause an outage, or it may cause part of the site to be broken. So do you have a plan for having backups or snapshots that you can easily, roll back data or roll back code when something happens like that, so to have very minimal downtime? And a lot of times you need tools for this. So how about upgrading Python versions? Right? If you're just running on a regular Linux server, usually that Linux ships with one version of Python, and especially something like Debian or Red Hat, they're a little bit slower to adopt new versions. So how do you upgrade from one version to the next? So there's just a lot of things like that that come with hosting a website that you don't initially think of until, things start to go wrong. In Aladdin's case, he summons the jinn, or the genie. He quickly learns the financial burden of providing these services. It grows exponentially over time. More and more maintenance, is required on a day-to-day basis. The only solution is to summon superhuman levels of efficiency. And in his case, that is the jinn. But we will use automation instead. So the things that we automate to reduce the amount of maintenance day to day are things like creating servers, creating containers, that's through The deployment process that I showed you, creating databases, all that happens automatically. Creating SSL certificates, updating DNS, all that stuff happens automatically. But error detection, right? So if a monitor detects that a site is no longer responding, sometimes there's some quick fixes you can do, right? You can restart the services. Is it a network issue? Is it a database issue? Or is it throwing actual errors, like 500 errors, and that's why it's considered down, And in some cases, you can just kind of automatically heal that by saying, oh, it's using all of its available memory or all of its available CPU. Let's just kill the process and restart the server, and then the site only has to be down for 20, 30 seconds, and no one really will have to notice it. It will kind of heal itself. So tools for doing this so that people aren't having to constantly do this on all of these different sites. And things like security. Monitoring traffic is a huge one. Bots, and I'll talk more about bots in a little bit, but things like that can also take down a site or just destroy the performance, and now a person has to get involved once again, and this stuff happens on a daily basis when you have more and more sites. So the last story that I will tell is that of Alibaba and the 40 thieves. And this is the spammers, bots, and malicious behavior that can bring a site down to its knees. So it all starts with Open Sesame. Alibaba sees that a large portion of web traffic is evil bots, attempting to brute force URLs. Here's a fun fact about Wagtail, and some Django sites are susceptible to this as well. You can actually quite easily take down a Wagtail site by just hitting it really hard with a lot of 404s. And that is because, for example, XML-RPC.php, that's most likely going to 404 on your Django or Wagtail site, right? But that is a major #1 vulnerability in a WordPress site, is that specific URL. So guess what all these bots are gonna do? They're just gonna start hammering XML-RPC.php to see if they can find it, or they can make it do different things, or they can try and exploit a vulnerability. So your site is probably gonna get a huge amount of 404 traffic on that specific URL. And in the case of, if you're using a content management system, it's probably going to look at all the pages in the database, say, oh, none of these pages exist. Let me check the redirects table, look at all the redirects in the database, and it has to look for all of them because it's not gonna find it, and say that doesn't exist. Let me check the Django URLs. No, that doesn't exist. Okay, now I've just done all of these really expensive operations to determine that something doesn't exist and it's a 404. So, 404s can be quite expensive, actually, and when you have bots just hitting them nonstop, you could see 100% resource usage all being dedicated to just serving 404s. So these are just some really odd things that you find that, bots can inadvertently take down a site. So Alibaba must find a way to stop these legion of bots. But how do you distinguish bot traffic from human traffic? Alibaba writes a Sentinel middleware in the reverse proxy to watch all traffic, identify patterns, and block the bots. So this is where we're just having to get more and more complex. It's almost like a war against, bots versus just keeping the site up. So in our case, we ended up having to do something like this. It's sort of like a rate limiter, but mainly it just watches traffic, looks for certain patterns, and when something seems to be falling into a really bad pattern where it's making too many requests, in a certain way, we will just temporarily block them for 5 minutes. And a lot of times that's enough to just make it go away without causing any harm to someone who may trigger it with a false positive. But that was only part of the problem. The worst part, arguably, is the bad humans. The 40 thieves use fraudulent info to open accounts and abuse and steal resources. So at this point in age, real email addresses are meaningless. Real phone numbers are meaningless because you can generate a Gmail account with a Google Voice in, 30 seconds, and those are both real, valid things that can be used for two-factor authentication, and, so those really don't mean anything. People can use that to bypass terms of service, right? And every website, if you have a sign-up form on your website, people are probably signing up with fraudulent info to try and steal your content or abuse whatever services you may be offering. In our case, we ended and this was, we had a CAPTCHA, we had everything, but these were like real people clicking through and just creating hundreds of accounts and doing more bad things that I'll show you in a second. In our case, we ended up finding a really great service that I'd like to share with you called MaxMind, and they have a fraud detection service where you can basically pump all of this information into it, like request browser, user agent, browser info, as well as their email address, and they will analyze that and kind of cross-reference it with known databases of people who are being malicious and actually score the results and say, this has a 15% chance of being malicious. So, this is nice, and you can use this. I am not a robot on some requests, but you can't use this across your entire site. And even more so, I am not a bad person. This doesn't exist as far as I'm aware, so it becomes, even more difficult to solve these kind of problems. So, like I said, we used MaxMind, and they have a min fraud service that can be used to detect fraudulent user info. So this was a really huge help for us. And just a couple more left. So the last problem, this is a newer one that started happening this year, and that is AI training. So this is just kind of a look at, this is a 30-day snapshot of some traffic. And you could see, in comparison to the graph, there's roughly about 10% of traffic at all times is bots. And these are normal bots, Bing, Google, crawlers, SEO tools, what have you. And they're fine. They don't, abuse the site. They follow the robots.txt. They're pretty well behaved, right? So an anomaly that we started seeing recently is a new bot that showed up. And if anyone here works at Meta/Facebook, I have a few words for you. But we actually were having some customers get fully DDoSed by Facebook. By their training API, bots. So we were seeing roughly 60% of traffic was just coming nonstop from like hundreds of different IP addresses, all for AI training. And for some sites that had slower, large amounts of content or slower, big databases and things like that that weren't optimized, it was just completely taking down the site because they couldn't handle the volume of traffic, So the reason you see dips in that is because we had just had to systematically block them temporarily for certain clients to keep their sites up, because it was just totally unexpected traffic. So, but they keep finding new IPs, they keep coming back. So this is like a new challenge that we have yet to totally figure out exactly how to work around. These challenges keep happening every single day. So, and the very last one that I'll show you is actual code injection attacks. This is another one that happens. So can your manage.py file download binary executables? Can it open an HTTP proxy to evade law enforcement? Can it run a Tor network? Can it mine Bitcoin? Yes, it can. So Python manage.py migrate, right? This is something we all run every day. But the question is, what is in your manage.py file? This is actually a real example, which has been slimmed down. But this seems unassuming, right? Manage.py, Django's command line utility for administrative tasks. This is actually downloading Node.js and unpacking it and running it on the server. And it can be used to run all kinds of nasty things. So this is not something that should be happening on a Django site. So this is, one of the many things is when you talk about bad people getting in and just trying to abuse services, code injection is a big one that you have to look out for. So Anyhow, this is just kind of a summary of some of the things we've had to deal with hosting 1,001 Django sites. Thank you very much.
Thank you for your talk. I was wondering how you'd respond to customers that, let's say, have these Node.js injection scripts into stuff that makes it to your environment.
Yeah.
If they end up having a vulnerability, what are the actions you take and how do you work with the customer to overcome them?
Yeah, great question. So in our case, those are almost always coming from the customers themselves who are, trying to do something bad that they shouldn't be doing. Code injection has never happened at that level for legitimate customers because they are deploying their code, from a version control system or something. But it's just kind of a reminder that if you allow people the ability to upload their own code, you will get some very nasty code. So we just monitor processes and things like that on the servers, and if an anomaly comes up, then we can immediately, either contact the customer or suspend the account.
Thank you.
Yeah.
Hi, thanks for the talk. I noticed you mentioned that you heard what you serve WordPress as well as Django websites.
Yeah.
Could you talk a little bit about how managing the two of those is different from the perspective of someone who owns a platform like this?
Yeah, definitely. So we actually manage them quite pretty much in the same way. We use that similar environment approach for both WordPress and Django. So the Django sites have a kind of perfected golden Python environment, and the WordPress sites have sort of a golden PHP environment that's also pre-configured for that kind of site. Both of them get the exact same permissions applied, so they get locked down and specific file system permissions, and then the code is loaded in at runtime and the process starts. So they actually behave pretty much the same, and then we constantly are doing patches for PHP and Python, and our plan is also to add maybe Node.js or Ruby or some other frameworks in the future. We just started with Django and WordPress because those are the vast majority of sites that we're working with.
Hi, thank you for the talk. Could you comment a bit on how you manage high availability in this case? So basically, if you have one site and then you spawn more,
Great.
To increase the number of lines. Thank you.
Yeah, high availability. So high availability is one of those things that we kind of think about as, in some cases, it's over engineering, right? It depends on the customer. So we've found that actually for most customers, 99.9% is a perfectly adequate availability for, within their budget, right? So in that case, we have a process that we can pretty much be guaranteed within that. If they need higher availability, then that's something where we're doing multi-systems or multi-regions, and it's a very similar process to that, but it obviously does double the amount of resources that's required on the back end. And we also have customers have staging sites as well, so it can triple or quadruple the amount of resources for the high availability. But yeah, it's actually quite a similar process. The same environment image is used in both environments, and the same code, like requirements.txt, is put into both environments. So yeah, and then it can be load balanced or have a failover type system. Yeah.
Great, thank you.
Given that Docker itself is not usually a security primitive, how are you isolating around Docker to secure the users from each other?
Great question. So everything within our system is really isolation is kind of the first principle that we follow. So everything, each site will have, first of all, its own Linux user and its own sort of trooted environment on the host, as well as its own trooted file system. And that's basically where root is basically where / equals their directory, so they can't get out of that. Then beyond that, we have Docker being run as limited users for that specific user, and as well as an isolated network for every client. And then within the container itself, they also have a isolated user within the container. So there's many different layers of isolation involved, and it's worked pretty well for us so far. Yeah, and then for the biggest, most sensitive ones will still be on a dedicated server as well.
I wanted to ask, do you only use Docker or like Docker Compose with the PostgreSQL service so that you have a whole stack, or have you just one database for all the Docker containers?
Yeah, great question. So we're kind of in the process of Dockerizing databases. Right now, we use high availability databases and have those kind of isolated on a dedicated database server. And then those are isolated on that server. So they're kind of separate right now. But we've been exploring kind of coupling them more with a Docker Compose type scenario. But we haven't done that yet mainly because of resource constraints, because databases need a lot more memory and I/O, than a website does. So putting those on the same server doesn't always make sense because the server is not, optimized for different things. So yeah, that's been kind of a work in progress.
Okay, thank you.
Okay, thank you.
Thank you.